Recently, I made a video about bringing in weather data from your outdoor weather station using a receiver and MQTT. Problem is, only certain values are brought in from the weather sensor. The rest are calculated on the display unit itself. So today we're going to recreate some of those missing sensors and bring them into Home Assistant. So let's get started. Oh, and by the way, I realize that 90% of you who watch my video are not subscribers. So if you can take just a minute and hit that little icon in the bottom right of your screen, if you're on a computer, and then hit subscribe, that would be fantastic. Would really appreciate it. It really does help the channel grow and helps me to be able to make more of these videos. All right, now let's get started. In a previous video, like I talked about, I show you how I set up MQTT and the weather station Raspberry Pi to receive the weather data from the weather station. This video is a second part of that, talking about some of the missing sensors. So if you haven't watched that video, I'll link it up above. Make sure you, over here, I'll make sure you watch that video so you understand what we're talking about here. Now, from that MQTT feed that we're getting from the weather station, these are the items that we're getting. And we're getting obviously the time, the model, ID, battery status, temperature, humidity, wind direction, average wind in meters per second, wind in max wind in meters per second, the rain since this unit was reset. I think that's when the batteries are put in there, or maybe once a year. This is the total rain for the lifetime of the unit for the most part. And that'll be important here in a little bit. UV values, UVI values, light lux values, modulation, some other things here related to the transmission, the RF part of it. So frequencies, RSSI, signal to noise ratio, and the noise. So those are the things that we get from the weather station. What we don't get from the weather station that we're used to seeing on our display panels are the feels like or heat index, the pressure, the rain rate, the rain this week, 30 days, month, year, rain 24 hours, and since midnight. And also, you notice that I'm getting the average wind meters per second, max wind meters per second. So I set this to a value in RTL 433 to send me US-based units, so I am getting the temperature in Fahrenheit, but for whatever reason, it doesn't convert this to miles per hour. So the wind will be converted to miles per hour in one of my sensors as well. All right, so those are the things that we're missing, and those are the things that we're going to try to build out today, or have built out, that I will show you. So first things first, let's go over to Visual Studio Code, which I have as an add-on to Home Assistant here. All right, so this is all of the relevant weather data that we're talking about today. I have a bunch of other sensors that are not displayed on this page, but I compressed it a little bit just so we're looking at what we want to look at instead of everything. All right, so again, platform is in MQTT for the data coming in from the weather station. And we're looking at the total rain over the lifetime of the unit. So that's in inches and comes in from the MQTT feed. We're looking at the wind speed in meters per second coming in. So this is value JSON wind average meters per second. That comes from the JSON feed, the MQTT feed. But then we do a multiplier of 2.237 and we round that to 3, and that gives us the value in miles per hour. We do the same thing with wind gust. So we're just taking the value in meters per second and we're bringing it in, multiplying it by 2.237 and rounding it off. Now you notice that I've done both of these within the value template itself. You can do calculations in your value templates, and if you've messed with Home Assistant for a while, you probably know this already. You can take values and you can manipulate those values within a template so that it returns something that you want. In this case, I want miles per hour instead of meters per second. All right, so we're also doing the Fahrenheit temperature measurement. So that's coming straight out of Home Assistant. I'm rounding that to 1. And then we also do the humidity directly from Home Assistant. I'm sorry, not Home Assistant. We do that from the weather station MQTT feed and the humidity from the MQTT feed. And we're going to use both of those to build out our heat index. Now, the thing about heat index is it's not just one calculation. If we come over here and look at the actual heat index equation, we can see that there's this really long formula. It's the regression equation of Roth-Fuzz. And that's how the weather services and everyone calculates heat index. But there are some additional conditions. So if the temperature is between 80 and 100 degrees Fahrenheit and the humidity is less than 13%, then there has to be an adjustment applied. If the temperature is between 80 and 87 degrees and the humidity is greater than 85%, another adjustment is applied. And then finally, if the temperature is below 80 degrees, there really is no heat index anymore. It's not hot enough to be a heat index. So then you have just a straight up formula for that. So we have considered all of that in our calculations here. So each one of these will show you that particular setup. So if the temperature is between 112 or 80 and 112, and the humidity is less than 13%, we're going to apply this formula on this line. If it's between 87 and 80, and the humidity is above 85%, then we're going to apply this formula. And then if the temperature is less than 80 degrees, we're going to do this particular formula. And then finally, we're going to do this formula here as a last resort formula. And then we're going to return this in units of measurement as Fahrenheit. Now I'm going to create a paste bin. I'll put all this in a paste bin for you all to look at, and I'll link that down below because there's a lot of stuff here and I don't expect you to watch the video and try to type it. Plus there's a lot of it to the right. You can see how long these formulas go on. A lot of calculations going on to make that entire long formula show up in here in this template. One of the things you'll notice too as we're doing the calculations, we're pulling in our sensor data for temperature Fahrenheit, and we're pulling in our sensor data humidity. That's why up here WH65 temp F and WH65B humidity, and you can see WH65B temp F and WH65B humidity, and those are the two things that we're going to use to calculate the heat index. Barometric pressure is a whole nother story. This is not working right. We've tried a number of ways to get this to work, but it's not working correctly. It doesn't match what we're getting back from our weather station. I also have a WH25 barometric pressure sensor that's standalone. It also doesn't match the formula. So for whatever reason, I think we're not doing stuff with the density, altitude, and a whole bunch of other things that should be done, and so that's causing some issues with the formula calculation. If you know how to do this, and you know how to make a value template for the barometric pressure, make sure you comment down below and let us know. That'll also let everybody else that watches the video know how to do it correctly so we can display it correctly. All right, so for the rain, we have a whole nother story with the rain here. So you remember that the rain comes in as a single value for the lifetime of the unit. If we look back up here at our input, you can see that our rain is one value, WH65B rain. We have to store values in the database in order for the values to be able to be acted upon later on. So we're taking point in time values and putting them in our database. I'm using Influx as my database backend, and in order to put values in, we're going to use a insert for the database. So you have these queries that you build in your Influx or for your Influx database, and you name them. Of course, rain 10 minutes ago, unit of measurement is inches, value template is value, and we're going to float that. This float part is important because otherwise you get long numbers, you get numbers that can't be calculated by the system. So you want to add a float, otherwise it's not going to work right. That's a very simplistic way to say what I just said, but you need the float. Group function first, measurement is autogen, and then this is the database that we're putting in. The field is a value, the database, or this is not the database, this is the measurement we're going to put it in. And then the value, and then where, and this is the rest of the query. The time is greater than now minus 10 minutes, and entity ID is WH65B rain. So we're now looking at rain 10 minutes ago with it from the entity ID of that WH65B rain, which is the sensor that comes from MQTT directly. So whatever the rain system is reporting, we are going to mark that in our database as the value. So these all are kind of the same thing. The value of the time is different. So rain yesterday, all of the rest are the same. We're looking at the rain and the time as a timestamp now, and then we format that timestamp and we use the time zone. Now you can change this time zone to whatever you need it to be. And we insert that. We insert rain 24 hours ago. We insert rain 7 days ago. And we insert rain 30 days ago. And then of course a year, and then the beginning of the week. And at the beginning of the week, you do the same thing with figuring out with this formula what the beginning week or beginning of the week is for your particular area. And then the month is the same thing. It figures out the first day of the month, and beginning this year figures out the first day of the year. Because you have a difference between 365 days ago versus beginning of the year. So January 1st to now, or 365 days ago, which is a full year from today's date. So when you first start all of this up and you build these sensors, they're all essentially going to be zeroed out for the particular time frame that you're looking at. So if you had 10 inches of rain in the middle of the month and you build this sensor in the middle of the month, you're going to have no rain until the month resets, or you're going to have just the amount of rain that you get from the time you start the sensor until it actually shows up. That's the one drawback. Now you can go into your database and you can enter these values based on what you already know. So if you know you've had 27 inches of rain this year already, you can go in, once you create these sensors, change the values of the appropriate these appropriate values. So let's say this one, you want to change this rain begin this year to whatever your rain is from the beginning of the year till now, and then there it will calculate it correctly going forward. But if you start this up day one, everything is going to be based on the value of your current rain setting, or your current rain value in your sensor. So whatever that MQTT value is that comes in. Hope that makes sense. In my mind it does, but also sounds very confusing. So anyway, let's move on. All right, so now we have all these values set into the database. Now we have to display them. So we create a bunch of sensors, again, 7-day rain, and the unit of measurement is going to be inches. The value template is going to be the current rain state from the MQTT feed from the sensor. So let's say the sensor says right now it has 25 inches of rain measured. And then 7 days ago, it had 20 inches of rain. Now it's going to tell me that the 7-day rain is 5 inches. So in the last 7 days, I've had 5 inches of rain. Pretty much all of these do the same thing. So rain this week, we're going to look at the current value of the rain from the rain sensor. And we're going to look at the value we stored from those values above in the database and calculate how much has come down since this period of time has elapsed. So 7-day and this week. So yeah, a week is 7 days. But again, 7 days is the past 7 days of rain. Rain this week is from the first day of the week that you set. So let's say it's Sunday. So from Sunday until today, this is how much rain we've had. 30-day rain does the same thing. Monthly rain does the same thing. Annual rain does the same thing. And so you can go on and on and on. The rain rate tells you how much rain you're getting. And that's for me, that's an important one because I like to see how hard it's raining. So your rain rate's going to be from the definitions. And that's one of the things to look at here too. Rain rate, and this is the ambient weather kind of definition site. Rain rate is defined as the rainfall in the last 10 minutes multiplied by 6. So 10 minutes times 6 is 1 hour. This is also referred to as instantaneous rain per hour. By the way, you can look at all of the rest of these as well and determine the calculations. We determine the calculations based on the definitions that we're getting from Ambient. I have an Ambient weather station. These definitions are based on what Ambient has in their weather station display models. So the calculations, a lot of these are done within the display units and not being sent from the unit itself, the outside unit. So the definition for rain rate is how fast it's been raining in the last 10 minutes multiplied by 60. So looking at Visual Studio Code here, we look at the current rain state, and then we look at rain 10 minutes ago, which is another value we stored in the database. And then we take that and we multiply that by 6. So basically we're saying if it's greater than 0, which means it's raining, we're going to multiply that value by 6 per the calculations on this page. So multiply by 6. And then return that as our rain rate. Otherwise, if it's not raining, it'll just log a 0. And continuing on, of course, we have rain past 24 hours, rain since midnight, rain started, and then we have for the rain event. And if you look over here, again, a rain event is defined as continuous rain. It resets to 0 if the rainfall is less than 1 millimeter in a 24-hour period. So yeah, and it says some weather stations calculate a little bit differently, just for reference to the user manual. So in our case, we're going to calculate the rain event like they said. If there's any rain at all and it's greater than that value, we're going to consider that as the amount of rain for this particular rain event. So if it started raining 3 hours ago and it's consistently above that threshold value for the last 3 hours, that's considered the rain event. If it stops raining for 24 hours, then that rain event has now elapsed. If it rains 3 hours, stops for 2 hours, rains some more, that's considered part of the same rain event. So we're going to continue to add that up, and then we'll show the value of the rain event in its totality until the threshold is below the threshold for 24 hours. And then same thing, rain epoch, last rain, and you can get all these definitions again from this page right here. And so let's go back to what we were showing here, some of our missing values. So we calculated our heat index. Pressure, I don't know about pressure. Pressure is very strange and doesn't seem to work correctly. Rain rate, rain this week, rain past 30 days this month, this year, 24 hours since midnight. And then we converted our wind to miles per hour from meters per second. So we satisfied cleaning up finding all of the missing sensors. And now we come over here, and what I do with all of this, obviously, because I'm a graph and data guy, is I have a whole dashboard built off just the new weather sensors that I use from the MQTT feed, and then these sensors that we built out. So looking at this, you can see that I have my outside temperature, my feels like temperature. Yeah, there we go. And weekly rain total, and rain rate are all zeros. I have these conditionally formatted so they don't display anything at all when there's nothing there. They're zeros or non-existent. So we've had no rain. For the year, 6.2 inches. Maybe hard for y'all to see. There we go, 6.2 inches. That's not the total rain for the year. I have not gone back into Influx and set my rain value for the year to match what has been the year's rain. If I did that, it would be a higher number. My monthly rain is 0. And of course, here's my humidity coming from the MQTT feed directly. My signal value, signal strength values. I have a little bit of an issue with my antenna placement and pulling the data from the weather station. So I watch the RSSI values to see how much signal I'm getting from my weather station. And then of course, lux, noise. This is all RF based stuff. This is telling me what my Raspberry Pi receiver is hearing from the weather station in terms of noise and interference and stuff like that. This is a windrose that I'm using, and it gives me, over the last hour, this is what I have it set to, plots of how many or where the wind's coming from and how strong it is, and of course the wind speed over time, and then some other stuff on here. But that's it. That's how I use all of that. I hope you found this useful. I hope that now, if you're doing this from my previous video, you're able to find the missing values that you probably didn't have before. Make sure you hit the subscribe button if you have not. Again, 90% of my viewers are not subscribers. It just takes a second to click that little button right down there and subscribe, and then hit the bell icon if you want to be notified of new videos. And let me know if you have any questions or updates or better ways to do this. I'm always open for that. And definitely, if you want to see something, some content suggestions, let me know that as well. And we will see you on the next video.